In this video, this is the second part of our task in which we are tasked to write and assemble a program to letter A, set the stack pointer equals to 90 hexadecimal. Letter B, put a different value in each RAM locations from 9D to 98 hexadecimal. Letter C, pop each stack location into registers R20 to R24. And last one, use the single step. Examine the registers, the stack, and our stack pointer. So now let's create a new project. Select Atmel AVR Assembler, and we will rename this project as Lab 7 Act 2 since this is our second activity. And then we will choose the path or the location of our project. Then click OK, and then we will click Next. And then we will choose AVR Simulator, and our device is at Mega 32. So let's select at Mega 32, and here it is. Let's click Finish, and let's wait for the IDE to load. So here's our IDE. Let's expand this one since we will be needing more space for our code. And I will try to type in the code here, and the code is provided to us. So I will just type in the code. You could also check it out in the description below. And now, since we are done with the writing of our code, we can now proceed to assemble to verify if there are errors or existing errors within this code. And unfortunately, there are errors, and I guess this is the error. I misplaced the L1. Instead of L1, I type D here. So let's change it to L1, and then let's try to assemble it again. And now, as you can see, there are no errors, so we can now proceed with our build and run, or assemble and run, or the debugging mode. So we are now in the debugging mode, so let me just adjust this one since we will be needing more space to examine the stack pointer and our registers. And let me move this one. Let me just fix all the things or the setup. So here's our CPU. We can monitor here our stack pointer as well as the stack pointer register. Here's the SPH and SPL, but also we can monitor here our stack pointer. So we can now proceed with our single step. The first out instruction doesn't seem to care on altering the values, but after the second out instruction, it is observable that the value has been changed to 90 hexadecimal. And as we go on with our register, since we are going to deal with the LDI instruction, since let's scroll this one, and let's examine and monitor R16 as well as the other register. So let's start with the single step. So the values has been changed from 0 to 1, and as we come across to the LDI instruction, the value that has been initialized to R16 has been set to our R16 register as well. The STS instruction, on the other hand, is just to store the values that has been declared into it and store it into the register that has been assigned into it. And after this instruction, we are now going over to the pop instructions, in which we will examine the stack pointer. Let's call this up from 90. As we pop on the first pop instruction, as you can see, the value has been changed from 90 to 9E hexadecimal. Same goes for the next pop instruction, in which the stack pointer is incremented from 9E to 9F. And we can observe that on the stack pointer. Going to the third pop instruction, It is just the same with the previous pop instruction. It increments the value of our stack pointer. And same goes with our last two pop instructions, in which the value is incremented and it has reached the value of 0A2 hexadecimal. And as we pop the values of the stack pointer, it is incrementing the value. And for our register, it is obvious that we had loaded the values of FF into it for R20 to R24. And we can also monitor our status register here, as well as our flag, so we can scroll it down here. And I guess that's it for this video, for this problem. Thanks for watching.